Good day, class. In this lecture video, we will be talking about predicate logic and quantifiers. Okay, so first, let us discuss what is predicate logic. So predicate logic, also known as propositional functions, defined on a given set A is an expression kani. So predicate logic is basically denoted this way. So mura siya og function form sa ato ang proposition, wherein ang iyahang variable or element nagdepende sa set kung asa siya gibasihan. So, in this definition, we have the set A as ang gibasihan sa ato ang propositional function. And ang element ani nga set moy matawag na tong murag variable sa ato ang propositional function. So it is important to note that predicate logic always have a set nga iyang gibasihan. That set is called its domain. So ang element ana nga set mooy usually ang element ana nga set mo ato ang input sa ato ang propositional function. So in other words, kana nga propositional function has a domain of the set A. Okay, so we also have what we call the truth set. So kaning truth set is that it is an element of the set A wherein kung ato siyang ibutang sa atong propositional function, ang iyang truth value is true. So kato tanan elements na ato ang set A wherein kung atong ibutang sa ato ang propositional function is true, kato siya karon matawag to siya karon nga mga element as the truth set, or usually denoted as T of P. So in ani siya no, T of P is consist or equivalent to X such that X is an element of our set A or katong atong gibasihan nga set, and that ang result sa atong propositional function when this element is inputted in the function is true. Or basically, ani lang siya. No? T of P is equals to X such that P of X masatisfy ni siya nga propositional function. So to understand clearly, na here is an example. Okay, so the problem is that we need to find the truth set of each of the propositional function P of X defined on the set N of positive integer. Okay, so ang ato ang set ani, no, murag atong set A kumbaga or atong domain is set N, which is consist of all positive integers. Okay, so here are the problems. First is that let's assume that our P of X is equivalent to X plus 2 greater than 7. So para sa inyo, unsa ang truth set ani? So unsa nga mga value sa X ang makapasatisfy sa P of X or ang makapatrue sa P of X? So as you can see, if mag-add ta kang 2 og 6 pataas, masatisfy gid ni siya nga proposition or propositional function. So we say that the truth set is consist of 6, 7, 8, and so on, or basically those integers that are greater than 5. Okay, so dito sa P, ato ang propositional function here is x plus 5, which is less than 3. So mangita tag value ni x, which is a positive integer, no, that kung ato ibutang diri should satisfy this propositional function. So mangita ta positive integer ha, so dili ta pwede mo input diri og kanang na point. So ang atong nakita, kung atong i-analyze, actually wala. Okay, so dili ta makakita o positive man, so wala po negative. So dili ta pwede diri kung masugod ta lugar sa 0, it's already 5. 5 is greater than 3, which is false. Kung mo start ta sa 1 and so on, mura gihapon. So we say na ang truth set ani nga propositional function is an empty set. That means na walay elements sa ato ang set A or sa ato ang set N in this example that could satisfy or that could produce a truth value to our propositional function. Now let's proceed to see. So p of x be x plus 5 greater than 1. So unsay maka-satisfy sa ato kani siya wherein mas dako siya sa 1. Well, basically kung mo start ka sa 0, it is already greater than 1. So kung ato na now this is already all the elements of the set n. So tanan positive integer can satisfy this propositional function. Okay, so that is basically what a propositional function is. Okay, so na siya gibasihan nga domain or set wherein mo'y mga possible na input niya, and then we will then consider if kana siya nga input ana nga propositional function could produce a true or a false truth value. Okay, so now let's proceed to quantifiers. Okay, note that if you want to know more about predicate logic, you can always look through the reference books or look at other lecture videos. They're available in the internet. Okay, so now let's proceed to quantifiers. So first type of quantifier that I'll be introducing is what you call the universal quantifier. Okay, so let's assume that we have p of x be a propositional function defined on a set A. Consider the expression this one. So kung ato ni siyang basahon, it reads kaning bali nga A, it is read as for every. Okay, for every ni siya. So kung ato basahon tanan, for every x element of A, we have p of x. Okay, p of x is a true statement. This should be satisfied. Okay, so kung false ni siya, dapat wala na siya diha. So basically, kung nakay p of x makita dira, that's already true. So we say that for all x element of A, p of x is a true statement. Or for all x na masatisfy ang ato ang p of x. So asa diri ang universal quantifier? This one. So this is the universal quantifier, our inverted A. Okay, so basically it is equivalent to this one. So sa ato ang truth set, pareha na sila og percent. Okay, so wait, wrong day. Basically, equivalent ra siya wherein ang ato ang truth set is composed of all tanan elements ato ang set A. Okay? So, yes. So, kani siya si universal quantifier should represent all the elements of the set A. No? Okay, so we have a note here that if, for example, this is satisfied, sa ato pa, our universal quantifier is true. Pero if not, sa ato pa kung for example na ay element ni A wherein kung ato siyang gibutang ni p of x is not true, nimo siya false, then this whole universal quantifier or this whole proposition is now false. Okay, so kung balik na sa to example, this one, this C, kani siya, since all of these elements, no, sa truth set ni kani, nga propositional function are all the elements of the set N, sa ato pa, this satisfy the universal quantifier. Okay. Next is, okay, to understand more, here's an example muna. So the proposition for all n element of n or positive integers, n plus 4 is greater than 3. So basically atong tanawon ani if this statement is true or false. Okay, so true ba ni or not? So note that ang ato ang set is all the positive integers. Now, tanaw na to of tanan ba nga element sa atong positive integer nga set masatisfy ani nga p of x or kaning propositional function. And as you can see, do magsugod ta sa 1 or sa 0, it is already satisfied. So we say that this propositional function, this whole proposition itself that involves universal quantifier is true. Now let's proceed to the second one. Again, our set is also all the positive integers, and we say that n plus 2 is greater than 0. This is our propositional function. Now let's find an n that then when we add to 2 is greater than 8. But that is again not the problem here. Since namang nagamit man ta og universal quantifier, dapat tanan element ni n kung atong ibutang diri should satisfy this. However, sa element ni n nga 1, 2, 3, 4, and so hangtod 6, dili na siya mo satisfy, di ba? So 0 plus 2 is 2, which is not greater than 8. So maingon na nato nga so na yung mga element ni n na dili makasatisfy aning propositional function. So makaingon ta nga this proposition is false or sayop ni siya nga proposition. Okay? Again, you need to remember that the universal quantifiers involve all the elements of kaning gibasihan nato nga set. Okay. Kung makakita mo, nagamit siya og for all, pero dili tanan element sa katong set ang makasatisfy ana nga propositional function, then that is not a true proposition or a valid proposition rather. Okay. The next type of quantifier is the existential quantifier. So existential quantifier looks like this one, the inverted E. So this is read as there exist. So kung ato ning basahon, again, it is same with the universal quantifier. It depends on the set defined. So again, if we read this, there exists an X element of A such that the P of X is satisfied or P of X is a true statement. So the inverted E is the existential quantifier. Okay, so basically ang existential quantifier is just kung ang universal quantifier requires all the elements in the set, si existential quantifier ang iyang kinahanglan is just one, at least one. Basta dili lang siya ma-empty set. Okay, kung naay isa lang ka element sa atong set A nga makasatisfy kang P of X, then that is already a true statement. If ang atong gamit is ang existential quantifier. Okay, so again, kung universal quantifier, tanan elements sa atong set A should satisfy our propositional function. Sa atong existential quantifier, there should be at least one element of our set na makasatisfy sa ato ang propositional function. So here is an example again. So we have here two propositions and let's see if these are true or not. So first we have every element, there exists an n element of all the positive integer such that mo satisfy siya ani nga propositional function. Is there an element of n that satisfy this? Well, basically, yes, there is. Unsa man? This is actually 3. Or, less than 3 below, which is 2 and 1 and 0. So, since makita man ta nga masatisfy siya, miskin duha ra ka element, duha ra ka positive integer as long as kana ang mga element belongs to this set, so this is already a true statement. If not, diri atong makita nga dili siya, no? So, this is not a true statement. Kaya wala man gyud makasatisfy ani nga positive integer. So, let's continue this on the next video since we are out of time.